Welcome everyone to this sort of hybrid live Mokume Q&A plus sign circle. There'll be a time for you guys to ask questions. I'm going to talk about Mokume and answer some of the questions that I've gotten on Instagram and Facebook over the last couple of days. I will ask before we start, if you're not actively speaking, maybe hear your shuffling. That'd be great. Thanks. So I had questions from people from all over the world, from everywhere from Australia to Poland to Arizona. So I'm really excited about answering some of those questions. And the first thing I wanted to talk about was just sort of a little bit very basic general, what is Mokume? Because we might have people here that are watching this that don't know what it is. It sounds strange to me because I live and breathe it all the time. But Mokume Gane is a technique rather than a material. So you can do it with any kind of metals. It's done with metal, and we would say non-ferrous metal. If you're doing the technique in steel, we would call it Damascus steel instead. So fusing layers of non-ferrous metal with time, heat, and pressure, but no solder. And here's a little billet that I'm going to just hold up to the screen. This is like an easy way to just say, you know, these layers of metal have been fused with the time, heat, and pressure, but no solder. They have not yet been forged down and worked together. And that's an integral, important part of the process that some people don't may not realize. But yeah, it's just because it looks great here doesn't mean it's going to work. Right? So it's a big part of the process is to work this down into usable sheet or rod form, and then create patterns so that you've got the gorgeous, unique patterns that Mokume Gane is named for. It's actually, the word actually means wood grain metal. It's a Japanese word, but you can make patterns, all different kinds of patterns. Here is a little tea container of mine with a close-up of just to look at some of the patterns that you can make. And yeah, originally a Japanese technique, but we do it all over the world now. And let's see, some of the first things that question that I got was this one fellow, Morrissey from Western Europe, I think, had a lot of questions. Basically, how do you make it? And all those things. So I can't cover all of it, but I will tell you that you can fuse these layers of metal with time, heat, and pressure a lot of different ways. And so you might encounter people that do it the traditional Japanese way, or you might encounter people that do it in a more modern way, which we call solid state diffusion bonding. That type of bonding is done with lower heat, but more time. And it's a little bit more repeatable. It's done in an electric kiln with some way to keep the oxygen away from the metal so it doesn't oxidize and fall apart from the oxidation. And that's the way I do it. I learned to do it the traditional Japanese way, but in today's day and age where, you know, you have to make a living, doing it the solid state way is more repeatable and reliable and all those good things. So real short intro on how I fuse the Mokume. It's done first. The layers of metal are chosen to be sure that they're compatible with each other. That's a long topic. So let's say we're doing copper, brass, and nickel, silver. That's pretty easy. Doesn't matter what stacking order you can choose. Let's say we're doing copper, silver. That's trickier, different temperature, and a lot trickier to get to stick together. So there's how about gold and silver? That's actually easier than silver and copper, but more expensive. So a little bit more alarming to do for the first time. So clean those layers very, very well. I use 1 millimeter thick pieces of metal, and put them in a torque plate situation. These are 1/2-inch thick stainless steel torque plates with grade 8 nuts and bolts. The nuts and bolts you can only use once or twice. The stainless steel you can use many times. It's a pain to machine. One question that I got from the Morrissey fellow or woman, I don't know which, was, do I sell kits? No, I don't sell kits. Mokume Gane is something that is pretty labor intensive and pretty technically difficult. And so the sort of ready-made kit, like, here you go, now you can do it, is not going to work. You really need to do some research and some learning and some classes in order to do it. And if you're not someone who's willing to go to your local metals store and buy some stainless and chop it up and drill holes in it, and then you're probably fusing the Mokume is probably not going to be for you. You can skip the fusing part and just go straight to patterning, because patterning is its whole other thing. I also teach classes in both fusing and in patterning, but I really separate them out because the fusing part is really fun, technically difficult, but you can go down a rabbit hole there and not get out for a long time. So, people, your friends say, well, what have you been doing? And you're like, look what I made. What are you going to do with the next? Well, I haven't figured it out, but look at these other 10 that I made. So it is important to keep your eye on the goal with Mokume, and that's to make finished objects, I would assume. All right, I'm going to skip around a little bit and talk about things that I remember, questions that have been asked of me. And one of them was, what kind of flux do you use for your semi-precious metals and copper alloys? And I found that to be a really interesting question because I don't use any flux at all. But I understand why the person asked this question, because Damascus steel will be using flux to fuse the metal. In non-ferrous metals, Mokume Gane, we don't use any flux because we're keeping the oxygen away entirely in a different way, either in a fuel atmosphere, like a forge, like a gas-fired forge, or by putting the assembly of the billet inside the torque plates in a stainless bag with activated charcoal around, and then carefully wrapped up and then put in an electric kiln so that there's no oxygen involved. So that's why we don't need any flux, because there's no oxygen involved until the metal is worked down to the sheet or rod. All right, let's see. I'm going to click over to some of my other questions because that's the limit of how many questions I can remember. All right, here's another one. Peter in Poland asks if I make titanium Mokume, and if so, how? And no, I do not make titanium Mokume. Titanium Mokume is most likely done on a much more industrial basis rather than a small art metalsmith basis because of the tools required. So probably the titanium, like if you are looking at titanium Mokume rings, they're made by really big machines extruding the layers of different alloys of titanium that have been fused together, basically just through really huge amounts of pressure. If you think 100 tons is a lot, there's even way more. Enough pressure that the metal just becomes like a fluid and it moves. And then so the maker of these titanium Mokume rings would buy bar stock that's big enough for a ring and nice and long. And what they'll do is they'll chop it up on a bandsaw, put it in their lathe, and create the rings that way. So they're not actually really fabricating the rings. It's a subtractive process of removing to make their rings. So I just think that's interesting because it's quite different than what I do, which is to fabricate the rings. All right, another question we had was also from the Morrissey was all about seamless rings. So some of you might have been sort of interested or seduced by this idea of making a ring with no seam. And I have done this, but I don't do it normally in my ring practice because it's problematic. So his question was, how do you do it? You take the square rod, basically, you drill holes, not at the very end, but about a quarter inch in from the ends, or 5 millimeters. And then you saw between those two drill holes and you open up that rod and then make the ring from there. First, you would twist the rod before you do all that. And he asked the question, which I certainly would have myself: how do you know what size ring that's going to make? So that's really tricky. And it involves a lot of practice and careful note taking, and also ring shrinkers and stretchers, a lot of forging, a lot of filing. And at the very end, you make a ring that it is seamless, but the pattern is not as interesting, honestly, as the patterns with a seamed ring. So you can, check it out online and look yourself, but seamless rings have really a look to them. There's always like an end grain from one side and the other side, and then there's some stuff in the middle, and it's just really not as easy to make beautiful, interesting patterns with seamless rings. So I kind of stay away from them because it's I can make beautiful rings, and if you do with a seam, if you know how to make your solder seam as tight and thin as possible, you're not really going to notice it in the final product, and you get better pattern anyway. Let's see, and there will be a chance for you guys to talk. So I'm checking out the other questions here. Okay, this fellow in Queensland asked me an interesting question. He said, I'm using salt and vinegar for pickle solution. It's used to clean up fire scale, and the billet is added to the solution when hot? Question. And this is also another interesting question because it tells me that this fellow is coming at it from the blacksmith angle, because pickle is kind of new to him. So I don't use pickle at all when I'm fusing. It's not needed until the further down in the process when you're actually fabricating objects with your pattern sheet or your pattern rod. So pickle is a salt and vinegar solution in real old school times. Nowadays, we use the chemical sodium bisulfate or things like Rio pickle or Sparex or that sort of thing. But yeah, I wouldn't use it until you're actually making objects with the Mokume. And also I wouldn't put the Mokume in the pickle while the Mokume is hot. That was another part of his question. And really Mokume, you don't want to torture it. It's been fused together with time, heat, and pressure. You don't want to be throwing it when it's when it's even at a black heat. I would wait for it to cool. I don't quench Mokume when it's hot, at least unless no one's looking. So, all right. So let's see. I could probably, I know Morrissey Fellow had a few more questions, but I want to have you guys that are here physically think of any questions you have. I see some things have come through in the chat. I'm going to talk a little bit about my upcoming workshops because they would help answer a lot of these questions. And then that'll just take me a couple minutes, and then I'll see what kind of live questions we have or questions we have in the chat. So my upcoming workshops, I'm going to share my screen. I promised some of you folks, oh, hang on, I did something foolish. Let me fix that. Okay. And so first, I'm going to, let's see, are you looking at a thing that says save the dates? Yeah, I think you are. Okay. Yep. So yesterday I sent out my email newsletter and I let you guys know that I do have some in-person Mokume workshops in the works, and that's very exciting. So it's the first time since, well, actually I did teach an in-person workshop in Long Beach last fall. So I'm going to be teaching a fusing class and an Art of Mokume class in the end of June and the beginning of July. And I promised you guys that came to the session tonight, I'd tell you a little bit more details. And so here we go. It is Mendocino, the Mendocino Art Center. That's where those classes will be. They recently got a new metals coordinator, and so she is on fire to get new classes up and running. And I'm really excited about teaching that. People are getting themselves sorted out there, I can hear. Let's see. And then also the one in September, that is going to be in Telluride. It's going to be, I've never been to Telluride. It's like at 9,000 feet. It's high, but September, it's going to be gorgeous. It's going to be the leaves everywhere. So, and it's going to be probably a small class. And I think it'd be really great. It's the AHA School for the Arts. Neither of these workshops are up online yet because they're still in process. But I wanted you guys to start looking at your calendars and see if you could maybe attend so that you'll be ready to jump on it when they do become live. And as soon as they're live on the host workshop websites, I will put a link to them on my website.
While Anne's taking a drink, I just wanted to mention Annette Campbell's question. And you can get to this when you have a chance, talking about soldering mokume.
Oh, okay, sure. Let's do the other two. I have one more image to share about my workshops because these are in-person workshops, but I recognize that some of you are a long way away from either Colorado or Northern California, where these dates don't work for you. So I'm going to share instead another image, which you may not be able to read this, but honestly, it was just a way for me to remember what I was going to talk about. I also teach online workshops, and those turn out really well. I realize I just took a picture. The thing I'm showing you is the one that's happening this weekend, which is a bit moot of a point. But see below also the chisel one that's happening at the end of April. And I think that if you do some research, you'll see that my online classes are quite popular. I work really hard to give clear images and video to illustrate every single step. And you get a step-by-step handout as well. And you also get access to the class for 30 days afterwards. You can look at the recordings. So it's a fast-paced 2 days interactive. You get lots of time to ask questions, but also afterwards you can go back and rewind and see it again. So I think it's a really great way to learn. And of course, I never would have done this if COVID hadn't happened. But I get really good feedback about these online classes. So I encourage you to check them out. The chisel patterning one, again, end of April. I also have one called Metamorphic Mokume. You can check that out on my website. And that's June 24th and 5th or 25th and 6th, something like that. So you'll see those on my website. Okay, so now I can say I'm going to ask. So yeah, Amy, you read me one of the questions from chat, and that was from Annette about soldering, just basically.
Yeah, and I'm going to take the spotlight off of you because Charlotte had an observation that I think is very relevant here. Charlotte, can you explain that, what you put in the chat about going up to 1450 for your soldering? Oh, let's see. Let's get you unmuted. Yeah, grab that when you have a sec. There we go.
I have tried several times to get a full jeweler's red brass layer bonded onto alternating copper and silver through 12 layers of those. And usually I'm at 1450 degrees now, and about 5 hours and 13 minutes is what I'm up to. And I can't get the brass, parts of it bond and parts don't, which actually makes an interesting looking pattern. But I would like to have the whole thing bond.
Of course you would. Yeah, well, I have one question for you, Charlotte, before I answer. What is the brass bonding to?
To the copper.
Okay. And you're doing all of that at the same time, the silver, copper.
Yeah,
and brass.
and I'm using fine silver. I'm using a brass layer, the copper from McMaster's car, and then fine silver, through
Okay.
the layers. And
What I find interesting is that you're blaming the brass. So the silver, so it delaminates. Where does it delaminate?
between the brass and the copper.
Okay. That's really interesting because I would expect you to be having problems with the silver copper bond at that temperature. And generally and you're fusing in an electric kiln.
Yes.
Okay.
And I'm putting it in a press plate like yours,
Mhm.
but then I don't. I've been putting it in a steel box with charcoal in the box.
Yeah. Okay. Yeah. Well, that all sounds like what I do, really. The thing is, though, that I'm a little more particular about what's bonding to what and what temperature I'm at.
Right.
Pardon me, ending with a participle or whatever the preposition. So if you're bonding silver to copper or brass, the temperature should be 1310 Fahrenheit. That answers another Morrissey's question, at least for me. That's what I do.
Okay.
If you're bonding copper to brass, the temperature should be 1450 Fahrenheit. Time-wise, I don't go longer than 2 hours. That time also depends a little bit on how much charcoal you've got surrounding your billet and how big your billet and torque plates are. As James Binion said, this is that you have to get the heat even all the way into the middle. Whoa, we got some feedback going on there. Good job, somebody stopped that. So if you have a big billet, or your charcoal box is big, your steel box your charcoal around is pretty big, you might need to go longer than 2 hours, but probably not. So yeah, you really, with solid state diffusion bonding, it's really not possible to have both silver copper and copper brass layers bonded at the same time. Because the ideal temperature for the one is different than the ideal temperature for the other.
All right. So,
some friends of mine that actually taught me Mokume, Earl and Jean and Jerry, what they came up with was what they call a ribollita. Does anyone like Italian soup? A ribollita is an Italian soup that means boiled again. It's basically taking all your leftovers and throwing them in a pot with some water and making soup out of them. And so they coined this term as related to Mokume, because what they will do is bond a bunch of copper brass layers and clean them up, and then go back in and stick silver in between them and bond that at a lower temperature.
Oh, that would be interesting.
You might try that. It's kind of a pain because, as you can imagine, but that's how they do that.
Yeah, my billets that I'm making are only 1.25 inches square, because that's what my setup is. And I haven't had, because I don't know how to do it, the courage to step up to getting the stainless steel bags.
Oh, okay.
So maybe I should just bite the bullet and do it.
That's a great segue into Dave's question.
Sure.
Anne, can you talk to us a little bit about stainless steel bag and maybe the magical material that can also be applied that's somewhat mysterious?
Yes. So I'll say this out loud. The question is, where does one get a stainless steel bag? Can one use some other material like a sealant applied to the metal stack? If you are Japanese, perhaps you might use a substance whose ingredients are highly prized and kept secret. And it's actually, it's a clay-like substance that is painted on the outside of the billet. And I've experimented with this, but it's done usually for those that are fusing in a gas forge, because you're going to a higher temperature, not spending as much time. This sealant doesn't generally last 2 hours. So that's a problem with the sealant. the stainless steel bag, you can just order. I just order sheets of. It's for tempering tool steel, so it's just really thin, 0.00 something of stainless steel, and I buy it from McMaster Carr, and I'd be happy to put a link in here if I can. And I can't multitask that much, but anyway, McMaster Carr stainless steel tool wrap is what it's called, and it's a pretty simple process. You take I usually use 10-inch by 12-inch piece, and you put you put it together like a U shape, fold it over, whack it with a hammer, fold it over again, whack it with a hammer again, so that you have a big tube, and then put your torque plate in that tube, and then just act like you're wrapping a present with some very chunky wrapping paper. I also use Kevlar gloves when I'm doing that, because you can cut yourself really nastily on the stainless foil. So that's what I do. But of course, Charlotte was saying she used the little stainless box, and that's honestly, I just haven't gotten to doing that. That would be a better thing to do if you can figure out for your setup how to do that easily. It's just the kiln that I have. If I have a stainless box, I'm going to need to take it out in order to get the things out from on top. And so I've got to have it placed down low that's safe to put it, and then get it with the tongs. It's just, it's a different sort of logistics setup. The one that I've seen that James Binion uses, his kiln is a top loader, and it's on the ground, and he just leaves the box in there all the time. It just opens the lid and grabs the thing out. So it just makes it a little bit easier on you, because you don't have to make the bag every time, but it's not terribly expensive. I think it probably costs $1 a bag. So it's not that big of a deal. All right. So I'm browsing through here. All the questions is great fun. So Joe asks, can you speak about determining the temperature you fuse your billets at? Have you found that 3 hours is adequate time enough for the bonding? And sure, Joe, I've found that 2 hours is adequate time. And there is the things have changed over the years. So depending on when a book was written that you might have read and learned from, people have done more experimenting and figuring out how long the bonding time should be, or what the temperature should be. For instance, I'm gonna grab a book here, so I haven't gone far. This book by Ian
Ferguson.
And here, I'm just spotlighting myself, because I realize we were just recording. Charlotte was big for a while there. So yeah, this book by Ian Ferguson, he'll tell you all kinds of cool things, but he'll tell you to bond your Mokume for like 8 hours. And that's been shown later that it's not necessary, and it actually can cause problems, because the crystal structure grows as the metal stays at temperature for that longer time. It's also just a real pain. Why would you keep the kiln on for 8 hours when you only need it to be on for 2? You're just wasting energy. So yeah, I mean, this is an incredible book, but over time we've learned more, and we know that the lower times is fine. And then the temperature to fuse the billets at, well, I'll tell you, the shorthand is that I took a class with James Binion, and he told me what temperatures I should fuse at. And I've adjusted things a little bit over time. I think that's partially because my kiln is probably a little different than his kiln was, or I was getting a little worried it was getting too hot or not hot enough. So I've adjusted things over time. But it's also to do with the melting temperature of the two metals that you're putting together. You want to stay below that. So you're doing solid state diffusion bonding here. At least that's what we're talking about tonight. So the temperature at which you're fusing should be well below the melting point of either one of those. And actually, I have heard 800 Fahrenheit is enough to get the molecules hot enough, moving around enough to start the fusing process. So, but I can tell you with the copper brass, I tried that once, Charlotte, where I had silver, copper, and brass layered together in one billet. And as I was programming the kiln, I was like, well, what temperature should I use? And if you have silver in the billet, don't go over 1310. That's because of the eutectic temperature that forms between silver and copper. So that eutectic temperature is like 1340, I believe. And if you go over it, you are no longer in solid state diffusion bonding. You have wandered into liquid state diffusion bonding, which is probably not something you want to do by accident. So basically, you're creating a third alloy between the silver and the copper. And if you're lucky, it'll be all right. But you really don't want to do that. If you're solid state, stay below 1310 when you're 1310 or below when you've got silver involved. Right. Let's see. Temperature is a good topic here, a popular topic. I'm seeing this fellow asking, what temps do you like for gold and sterling silver? And 1310 Fahrenheit. That's what works for me. I think just because I like to push it, I think Benyon told me to use 1300, and I was like, yeah, well, what about 1310? So, everybody has their own little things that they do, because they're sure the one thing they did before was why the billet fell apart, right? I had a time period where my billets were falling apart, and I started blaming the gloves. Sure, it was the gloves. Stopped wearing gloves. I don't wear gloves when I'm scrubbing the billets anymore, because I got suspicious that they were causing delaminations. I have no idea if that's true or not. They don't delaminate anymore, and I don't wear gloves. So there you go.
Wasn't it the argentium or something that you had a bad batch of silver?
Oh, well, I've never actually fused argentium. I always just do sterling. But yes, you're remembering that I suspected that the sterling was contaminated by germanium, which is in argentium silver. Yes, I was suspecting that. I got a bad batch of silver from Rio. But
and it's not in the questions in chat, but I have a question on behalf of Dave, our person who's newly excited about Mokume, and it will fit right here, which is the importance of cleaning your billet stack, your layers.
Of course. Yeah. And that's something, when I first started fusing Mokume, I was very, I learned, distilled water, Scotch Brite and simple grain, rinse, and then keep in distilled water until you dry it, stack it, and fire it. Don't leave it lying around. Copper will start to oxidize within 2 minutes in the air. So you got to keep the air away from it. If it's not actively being scrubbed or rinsed, it's in its little bath of distilled water until you dry it and stack it and get it in the kiln. Over time, I've learned more that that first part that you do, when I was saying, look at my pretty billet, there's so many ways to screw it up from this point forward. So I used to blame, when this started to fall apart, I used to blame it on the cleaning, but I don't think it was the cleaning. I think that the learning curve of what to do with this to get it down to the workable sheet and rod, and how you do that is probably more important than the cleaning. So people get all obsessed with like, oh, there's a scratch on it, you got to sand it with 600 first to get the scratch out. I don't think that's necessary. I do think it's necessary to degrease it. And I like using the Scotch Brite and the simple green, because I believe that a nice tooth is better. Like, you would not want to go on your polisher and polish your metal nice and shiny, because now you're kind of closing the pores. That's a very non-scientific way to say it, but you're not giving more surface area available for it to bond. So I like the Scotch Brite because it gives it a nice matte surface finish, and helps it bond.
Okay, we have a couple of good questions that have popped in. Back to the question of temperatures for all gold Mokume. I assume that Wilson's talking about like a rose gold, yellow gold, some different colors of gold.
Sure. Yeah. So gold billets with palladium, not palladium white gold, but palladium. Yeah, I have used, it's You're making me think now. I think it was 1350 is what I use for gold to gold. I don't honestly do that all that often. So I do custom rings with just gold or just palladium, but it's not as often because the cost is 2 to 3 times as much. So it's the rare customer that's up for that. And boy, do I make a tiny billet then. As tiny as I
They
can.
have is people with little tiny fingers. And then so Demian says about talking about alloys, and now this is going to meander into one of Anne's favorite topics, which is patinas. But you want to talk about alloys?
Yeah. Okay. So I see Damien asking what alloys do I use to make high contrast black and silver pieces, and that he started to experiment with pure silver and an alloy of 80% silver, 20% copper. That's interesting. But he's learning about Roksho. And so let's take those 2 things separately, because the first things he's asking are what materials do you use to get contrast, and then that Roksho, that's a patina, so that would be a surface coloration of the alloys. But first, let's talk about how could we get color without having to do a patina, right? So the best color contrast that I can get for my rings means that I need to find native. The native color of the metals need to be as different as possible, because I don't want any patinas on a ring, because the customer is just going to wear those patinas off. So for me, the highest contrast I could get would be palladium 500, which is a 50% alloy of palladium and silver with sterling silver. You could use fine silver too, but I prefer sterling because it's a little stronger. And that's a nice dark gray, honestly, the palladium 500, and it's a better gray than palladium 950. It's a darker gray than palladium 950, which is a bit strange, but true. So that's how I would get the highest contrast, not black and silver, not on a ring, but I'm seeing he didn't say rings, did he? He said pieces. So I'll tell you, to get high contrast on a vessel or a tea container, like I have a lot of pieces that I've made with silver and kuroshibuichi. So by silver, I'm using sterling just because I like the strength. But the kuroshibuichi, this is a Japanese alloy, and it's basically copper with just as little percent of silver as you want. Like 5% silver will give you a nice dark black with a patina, a very simple patina. Here in the US, Baldwin's patina, it's not available. Baldwin's patina is not available overseas unless you can convince someone to mail some to you from the US. But you can do the same with ammonia, and don't quote me on this, I think it's cupric nitrate and a couple other things. You can research and figure out that patina, but it's really an easy patina, and the kuroshibuichi will go quite dark. Or, of course, you can use the Roksho, which Damien asked. And the Roksho is also available in the US and Japan. I don't know if it's available in other countries, but here in the US, you can order it from Reactive Metals, and they order it from Japan. So if you speak Japanese, you can order it on komokin.com in Japan. But it's a complex patina. It would take me half an hour to describe exactly how to use it, but it'll give you a nice black with kuroshibuichi as well. But the Baldwin's patina is so much easier. That's what I use for that. I only use the Rokusho if I'm trying to get the copper red, or if I've got multiple things going on. The Rokusho gives you a thicker patina. It's a little bit stronger and thicker than the Baldwin's patina, but it's a lot of trouble. All right, let's see. And let's see, so many fun questions.
Yeah, we've got 3 new questions, and I'll curate them if you like.
Sure.
Real quick, back to revisit the temperature question. Wilson asked about temperature for an all gold billet with palladium, not palladium white gold, but actual palladium.
Mm-hmm. We covered that one.
Covered that one? Okay. And then, so moving on to technique, we've got a shaping and etching question. So the half round profile on a twist without lose? You want to go ahead and read that for the people that
Sure,
can't see it.
sure. So Wilson's asking, how do you get a half round profile on a twist pattern ring without losing the pattern? Well, that's just so much fun. So you can choose how whatever you do, you're going to affect the pattern, right? So say you've taken a rod of Mokume, it's a 6 millimeter square rod, you rolled it in your rolling mill until it was 4.5 millimeters. You twisted it a bunch of times and you forged it into a rectangle. So now what do you do? Because you know that the client asked for a domed ring. So there are two ways you can do it. And if you like the pattern and you don't want the pattern to change, well, you can change it as little as possible by, rather than filing off the corners of your rectangle, basically, you can run it through a rolling mill. That's the lazy way, right? If you have a rolling mill that has a half round roller, so it's flat on one side and it has a domed profile on the other side. Now, if you do that, you're going to stretch your metal out. There's less waste, right? Because you're actually using all of that rectangle. It's being forced into that half round shape. But you also stretch it out. So maybe your pattern, instead of a tighter twist, it's a looser twist. And maybe the client's not going to like that. So the other thing was you can take that rectangle and just go ahead and, you could hammer it, right? So just forge it. It's a rectangle sitting on your anvil. You take a low dome hammer and you push down the edges of the rectangle. You're just hammering them down. You can get them down pretty low. It's not going to get it all the way down to the anvil, but you can get it into more of a dome. And that way, the way you're not pulling the metal as much, you're squishing the metal more directly down. So it's not going to pull the twist out as much. Third option will change the pattern the most. And that will be to take that rectangle, roll it into a ring, solder it, tap it round, and then file off the outside edges of your rectangle until you get that half dome profile. And I'll tell you, I do all of those things depending on the order, depending on the final pattern that the client wanted, depending on me having X amount of material and I need it to be this millimeters wide and this millimeters long, because that's what the client ordered. I'll do a combination of all of those things to get to that end point.
All right, great. Well, Marla asked about, she says, I have experience etching of copper in my silver copper Mokume Gane ring. I have experience etching. Oh, I see, yes. Do you recommend anything to protect the copper from etching out during wear? Oh, this is a good one.
Those of you that know me are like, oh God, no. So my recommendation is to make another ring using gold and silver instead of copper and silver, because that is always going to happen. You're always going to get etching when you have silver and copper together. For giggles, you can Google, why should I not make a silver copper Mokume Gane ring, and a piece by James Binion will pop up, and he talks all about it, and he's got an experiment and visuals to show. But basically, it's those of you that have done the galvanic etching on purpose, a silver copper ring, you are creating exactly the same experiment, except you're doing it on your finger. So the copper and the silver are different galvanic scale. They're different on the galvanic scale, and the lower, the less noble metal is the one that etches. So the copper will etch, one's a negative and one's a positive, and your sweat is the catalyst. So that's why the etching is occurring. And I'm sure Marla's like, yeah, I know all that. How can I stop the etching? Well, so you have to do something to have that not be in contact with your skin. You could experiment. So I'll try and be just pragmatic here and say, let's see, those of you that are not
economic assistance, humanitarian assistance. We're giving more than $1 billion of direct assistance to Ukraine, and we'll continue to aid Ukrainian people as they defend their country and help ease their suffering.
I'm trying to see if I can mute without. I mean, I realize I came in and All right. I think whoever was listening to Biden has muted themselves. Okay. That was hilarious. Okay. So trying to be open-minded about protecting copper and silver from etching. Experiment with some of those. There are ceramic things. They're made of like nano ceramic thingies that you can do as a coating. That's the only that's a real high-tech new thing that people are doing, and that's the only thing that I think that you could do. You've got to somehow protect the ring from actually physically touching your skin, and anything like Renaissance wax, nail polish, spray on lacquer, those are all going to wear off on a ring, but this new nano ceramic might protect it. Yeah, that is all I have to say about that.
Well, Anne, I think that you have answered all of the questions in chat. Do you want to just open it up for or what did you want to do next?
Sure. Well, yeah, absolutely. We haven't even gotten people to talk live, but we've got one more question, and it's about etching. So what do I etch my gold, silver Mokume rings? And that's a fast answer. It's nitric acid, and 70% fuming nitric acid, 1 part acid, 3 parts water. And how long? Just keep an eye on it. The nitric acid is finicky. It depends on the ambient temperature in the room. It depends on how much copper has been dissolved in that solution, and perhaps some other things that I can't recall right now. So yeah, I check it every 5 minutes, and depending on the strength of your acid solution, that might etch faster or slower. Yeah. All right. So yeah, let's, I'm gonna just sit, for a second and let you guys, anyone who wants to unmute yourself and ask a extemporaneous question without having to type, please do so.
And are you going to keep recording for this part?
Maybe we should stop. It's been ages, hasn't it? So, okay, well, let me do we're going to stop recording now. So thank you for joining us here at this live Mokume Q&A, and please, yeah, all right. See you again next time. All right, do that.